Okay.
Um,
So we'll just let the conversation flow, naturally. Wes, I'll do a short intro. Thanks for sending your bio, by the way. I don't think I need to read the whole thing, but we can start with yourself and introduce your work, and then we'll just take it from there.
okay, sure. So where do I start? I guess you could say the simplest explanation for my bio is that I'm an early career scientist, early kind of postdoctoral in a way, because I do have my PhD, but postdoctoral also implies you're on a particular academic path, and you have particular relationship with your institution or your advisor, and I don't think I have that. So currently, yeah. So I did a brief postdoc at UCLA, which is where I got my PhD. But then I put the kibosh on that and went into industry after a couple of months, and that was well and great for a while too at Amgen, and not necessarily like data science related, but I learned a lot about pharmaceuticals. And then when COVID happened, which was really right at the start when I joined industry, a lot of things changed, and I learned a lot about how data influences decisions. And of course, I mean, I've known that that's like a thing that as a scientist. But then when you actually see when you see the rubber hit the road, and how companies shift directions, you start to question a lot of things. And I'm already someone who questions a lot of things. I think I mentioned that in my bio as well. And eventually Amgen decided to move directions and let go of all of their neuro team. And so I thought, and this is well before I realized that was happening, but I kind of implicitly knew, whatever is going on is not sustainable. I sort of had this sort of sixth sense about that sort of thing. I actually applied for a grant in Korea, which is where I'm at right now, looking for foreign scientists to do research projects. And this is all to say that although technically I am postdoctoral in terms of the time series of my career, technically I'm a brain pool scientific fellow now because of this Korean grant. And so that comes with some degree of independence and some degrees of expectation about the caliber and scope of my work. And I'm saying a lot. Sorry, this is my first time on a podcast, but I guess I'm somewhere between postdoc and professor in a way. Although as grandiose as that sounds, I actually have to start looking for professor jobs really quick at the end of this grant. So we could talk a fair bit about why I think the way I do about certain things. I'm not specifically a data scientist per se, but I've taken, of course, statistics classes. I've taken classes on machine learning. Really more of a wet lab, quasi-academics, quasi-industry sort of guy. And I think that's given me quite the unique perspective when it comes to looking at how data is being used or misused to guide various policy, especially these days. And it's particularly my experiences within academics throughout years of being at UCLA. And then my time at Amgen really informed a lot of what I know about how science is done and how data are collected. And we can talk a bit more about that. But I guess if you guys have an expectation about having a discussion about what my thoughts on data science.
No worries. Dominic.
Yeah, maybe start with, Kevin and I were arguing about how to pronounce neuralurgist or neurologist. Maybe you can start with that. Tell us about
that's that. A little joke. Yeah, so I like jokes. I like who doesn't? How do I say? Neuralurgist is the pronunciation. It's just a neologism of neural and ergos, which is like a Greek working with or working on, acting on suffix. And I always liked the idea of thaumaturgy, or a type of magic. And turgy or ergy is that Greek suffix. So if you add that on to something like metallurgy or thaumaturgy, like I just said, you get sort of the idea of like working with or the act of working on that thing in the prefix. And so neuralurgy is working with neurons, which is basically what I do all day. And so, yeah, I put that as like a kind of a jokey sort of catchphrase. I get a lot of, you see on Twitter, which I'm more active on than I ever have been in the past. I started my account in like 2009 or something, 2008, 2009. I really didn't use it much until maybe 2020.
That's
and
how
there's a reason
we
for that.
met, actually. Yeah, that's how we did. Because you were questioning the data that was coming out that was dictating policy. And I believe the first instance was something tied to the Reed model versus the Great Barrington Declaration. And I remember you talking about how the data is the models are wrong. And I was like, who is this guy? You know, and so yeah, because and then you went private, so I had to find you. I've had to find you through 2 accounts since this whole thing started.
Yeah,
but
so
you know,
yeah. So so the Neuralurgist is like a joke about how people will put their PhD in their bios and say like, I am this, you know, professor of blank, or I am some sort of important person, right? Like, bro, you're just a nobody. In most cases, you're a nobody. You know who's somebody? Actually famous people. Like Joe Rogan is somebody. I'm sorry to say, but that's the truth. Even someone who has you know, doctorates of questionable you know, I don't want to say
expertise.
Expertise, like Joe Biden's wife. Like, sure, she has a doctorate, but where is it from, and what's it in, and what's her thesis on, and what's the impact of it? Like, there are, like, I'm gonna sound like Jordan Peterson here. It's like there's hierarchies of how good a doctorate is. There's hierarchies of students. I can tell you that. I've created a lot of papers. There's hierarchies of science. I've read a lot of papers and you can see the hierarchy of how good a work is and how thorough it is. And there's hierarchies of doctoral degrees. Sorry to say, but that's just reality, right? So yeah, I mean, someone who puts their PhD in their Twitter profile, I'm just thinking like, okay, you want some authority, you want people to listen to you. I get that, but I'm gonna poke fun at the concept. So I put myself as the supreme neurologist PhD, something like that on my Twitter profile, just for laughs, right? And people ask about what that is all the time. But yeah,
that also happens in corporate a lot, because I spent a fair bit of time in banking. Everybody loves to be a vice president of some sort. You're like a first vice president, and an electrical vice president.
Oh yeah.
An ultra vice president.
At Amgen, it's like, you know, you have director, executive director, various levels of VP, things like that. It has a role. I mean, this corporate stuff does have a role. Not everyone can run their company like with a sort of flat structure like Tesla. Sometimes you do need to have like a hierarchical model, right? Of course, hierarchies and everything, right? Depends on whether or not how efficient it is. And I'm sure other people can talk to that. I know Alexandros Marinos has his company talking about how efficient a company can be, and that's another bag. But yeah, very, very much just poking the fun at the concept of Twitter names there. But I did go private, and there are reasons for that. I used to be a lot more kind on Twitter, and then over time, the whole last 2 years just made me very, very much jaded with the whole, oh, wow, academics are saying these things? Like, oh, you're actually lying, and you're okay with that. You're really, really just not being a great person.
Could you give us some examples of, I mean, because that's how we met, when you started calling out bad data modeling. And I started, you know, going back, and you have caused me to read more scientific papers than any individual on the planet Earth, okay? And
yes, that's a victory.
And not only that, I have to do it because I want to argue with you about stuff, and then it's like, oh, wow, he's right. So could you talk
I don't even want to be right. I just want to learn more. That's like basically it. Like being right is sort of auxiliary to, being right in a debate is auxiliary towards searching for the actual truth, right? To me, that's what's important. And the entire
models that you've seen that are wrong, and how you come about what's going on in the industry, because this is about data ethics.
Sure. I guess The Great Barrington Declaration, those guys in the beginning, I thought that they were wrong. Honestly, I thought that they had it wrong. I looked into, why, like, okay, there's how to say, everyone has varying degrees of wrong and right. When you understand that people often have a motive or a story that they're telling, then you can sort of assess to what degree they're wrong or right. And that's how science is done anyway. Like, there's no such thing, like, I guess I have to say this now too, like, there's no such thing as like a scientific fact per se. When you realize that everything is just Bayesians and like whether contextual observations, you guys are taking that really well. Like, most people would be like, there's no such thing as scientific fact. What's truth? It's stories. We tell stories.
Right. Well, science is a process to find the truth. It's never settled, right? And then the more we learn, the more we learn. I mean, look at physics, right?
Actually, I was in a conversation with some journalists about distinguishing facts from truth, and because truth seems to be something more like an assertion, while facts are something you verify or something, or maybe got it the other way around. Because there was a point one of the journalists made about back in the day, religion was the truth, or myths were the truth, and maybe to a certain extent, myths are still the truth. That's an interesting, angle to get into, Wes, especially now that we're inundated with a lot of false narratives and disinformation on social media. How does a scientist navigate that, or how does a citizen navigate that? I mean, just to interject a point, COVID was probably the first time many people in the public domain got exposed to such a huge amount of scientific or pseudoscientific data in history. I think it's the first pandemic we've had during the time of social media. I mean, even SARS was around. Even I don't think Facebook was around when SARS came in. So this is a new thing, for everyone. Seeing all these papers and some are bogus, some are not so bogus. I mean, it must be very overwhelming for a lot of people.
Well, it's not just the papers themselves; it's the reporting on the papers, right? So you have the first layer of scientific gobbledygook, right, which is the paper itself, the description of statistics, which are not necessarily always right, okay? Like, you can go up to any poster at a conference, I've done this before, and just look at how they do statistics and critique the methods, and you'll find something wrong, usually. Like, not all scientists are good at statistics. They oftentimes just plot their data in GraphPad Prism and then do whatever statistical test they think is right. If it doesn't work, some scientists, not all, will just mess with the test, mess with the tails of the test, to hack their p-value to make it right. And I over-rely on some p-values to assert some sort of fact-finding is also a problem. So that issue is one side of it, like the actual scientific conduct part of it. Then there's the other aspect of, was it even reported properly in the media? Did they even understand the caveats of the study, right? And so you have two like the left hand and the right hand aren't always talking to each other, right? And the right hand doesn't even know how to open and close its fingers sometimes, right? So like it's sort of an analogy how that works. I think I want to get back to Kevin's question in a second, but there's a lot of issues with how we basically, the regular citizen has almost no way of assessing this, because the regular citizen has no proper framework for understanding scientific data. Like, that's basically it. The scientific data is preached as fact, but we have basically taught people factoids when they're growing up. If you don't have a framework for assessing how things fit logically in a, I guess you could say, I call it like just a time series understanding of the world in a parsimonious way. If you don't have like a parsimonious worldview, you have no way of actually assessing scientific papers. So you could say, yeah, SARS-CoV-2 is totally 100% zoonotic in origin, right? And that's like, that's the I guess you could say that's the orthodox viewpoint of the scientific establishment. It's been the orthodox view for the last 2 years, even though there's data that has been chipping away at that idea. But the 100% zoonotic emergence of it is orthodox. But if you have a cogent, parsimonious worldview from various fields of study, genetics, evolution, thermodynamics, geography, geopolitics, understanding how real research is conducted, things like that, understanding how research is organized and funded, right? Understanding how geopolitical entities shape safety protocols and collect animals, things like that. You have to have like sort of a wide net to understand reality at best, and even then it's going to be imperfect. And that sort of worldview, a cogent worldview, will take in the bogus orthodox views and say, okay, this is why it's wrong here, here, and here, and here. I might not have the true idea of how something like the emergence of COVID happened, but I don't have the true idea of how it happened, but I have ideas of how it didn't happen and a model of that, right? Using basic statistics and Bayesian understanding of various processes, right? But the regular person just thinks that, oh, this facts are facts. Like, that's why you have things like fact checking, right? Which is entirely just an enterprise based off of, I guess you could say, just I call them disembodied factoids, where you can say something true or that sounds true, but contextually maybe, this is the key point, contextually it's just not accurate at all, right? Or it's spun in a certain way to use like weasel words that say like, oh yeah, blank is X is Y, but then they ignore it only in this context, or they over rely on fringe cases to assert some claim has veracity. I don't know if does that answer your question or not. Most people in the age of social media, factoids can just be spread very quickly. Like, I didn't necessarily intend on having a conversation about the fundamentals of truth here, but basically you have to have an understanding of like a lie can spread quicker than the truth, right? What's the saying? You guys know the saying, right? Like a lie can spread around the world.
A lie gets halfway around the world before the truth gets its pants on.
And that's a mathematical. That's how it works mathematically. That's an axiom. Like truth is nuance, if anything, contextual nuance, and that takes just more bits of data, more bytes of data.
Takes more effort. Takes more energy. Yeah. Well, yeah. It answers question. In fact, I want to do a follow up maybe after what you have to say about Kevin's. That what I'm getting is there's at least two factors there. There's the platform issue, which is because you have social media, then it just enables disinformation flow or information flow. And then later, I want, if you don't mind, maybe we can bring it back closer to your work. Is there a neurological explanation of why this is the case? I mean, are our brains wired to appreciate lies or to generate lies? I don't know if that's a good way of phrasing it. Yeah, but yeah, that kind of, I don't mind going in this direction. By the way, it's a very relevant issue in data ethics and society at large.
I'll get to that in a second, but I wanted to answer it. I've been putting off Kevin's question, but what models were wrong, Kevin? Like I said, I talked to the Great Barrington Declaration people, Jay, his colleagues at Stanford, who I'm blanking on their names. I'm sorry. I have a computer in front of me, and you guys do too, so you can Google that if you want. But they initially had this study about seropositivity in San Francisco, and I just didn't buy it because, of course, if you want to address some common criticisms about their study was like self-volunteered people from, I think, a Facebook ad that wanted to check their whether or not they were positive or had been positive for SARS-CoV-2 infection back in, I think it was April, very early April. You could have issues with the antibody specificity or how accurate the tests were. I thought they were over-reporting. They reported something either in the teens, I'm blanking out, it's been 2 years since I looked at the study, something like that, maybe teens or even more than that. Martin Koldorf. Yeah, I mean, these guys are, yeah, they're actually, they're not terrible scientists. And I should say, I disagree with people that doesn't make them terrible scientists or anything like that. If anything, it means that I'm learning. And I think basically their seropositivity study made me think, well, how could it be that SARS-CoV-2 has had such a high, perhaps in the teens, seropositivity by April 2020? That sort of, if you have one framework of understanding, right? Oh, SARS-CoV-2 came out left China in January of 2020, right? How could it have spread to San Francisco so quickly and infect, some 10% or more of people, right? At that point. But what if it had leaked out earlier? What if it had, so when you start to think about the data that say, oh, it came out maybe in September, October, or even August of 2019, you look at Italian data, things like that. People, athletes from various, was it military world games, something like that, getting sick. When you take your model and incorporate more data into it, right? You'll get a result that then can make sense, which is why the Great Barrington Declaration people were suggesting that in fact the seropositivity was higher and people weren't getting that sick, right? So why shut down all the markets? Why pump all the money into the markets? Why invoke all these lockdown measures when in fact our data suggests that it's not as bad as we thought it might be? It's novel and we should have caution about it, but it's not nearly as bad as we thought it was. If you consider other factors about timing of origin or release and basically risk stratification and comorbidities, and assess the data in the most holistic way possible. A lot of people get hung up on like, oh yeah, like it kills like 10% or 20% of the elderly or something like that. Well, yeah, but that's the elderly. What about me, right? What about kids? It's of almost no risk, especially if you have a good diet, exercise, take vitamin D, some people take zinc or vitamin C, things like that. I'm not that sort of doctor, but I mean, basic vitamin supplementation is also something that is good for health, right? So that's one of the things that I think, circling back to what Kevin said, that's where I initially disagreed with the model, but then when I read more, I realized, what, this is actually not half bad. This actually makes a lot of sense. And the fear mongering that was going on was actually based off of very cherry-picked information, like watching people keeling over on the streets of Wuhan, China, which is of course an anecdote and it should be paid attention to, but does it reflect the actual numerical reality? No, right? And Dom, to answer your question, are we hardwired to, what was it? Are we hardwired to accept lies?
Yeah, I was saying there were at least two factors that you mentioned. One is a platform issue, like when we now have social media. Yeah. But at the same time, I'm gonna assume, of course, feel free to correct, that disinformation existed way before the internet, and the internet just aggravated it. So what is there something about us that's hardwired for it?
It's like I said, it's just the mathematics of information content. Like, so I didn't specifically say what I did during my PhD. I studied cocaine odor conditioning in mice. In awake behaving mice, you stick head bars on their head and you make them walk on a ball. You record their brain signals. In my case, the novelty was that we were recording from like a world first 512 channel electrode array in 2 regions of the brain, yada, yada, yada. Basically, I showed that could have systems, brain region wide correlates and cross region correlates of memory of a cocaine paired odor cue, which is neat in and of itself, right? Like, okay, you have inhibition in the frontal cortex, and that's correlated to each subject's preference to cocaine paired cue, right? We oftentimes sweep individual variability under the rug in science, whereas that's actually one of the most interesting things about drug responses and preference tasks and learning tasks, that not every mouse gets it and not every mouse dies from a drug overdose. Like, what's the source of that variability? Can we tap into that? And you can do linear regressions on that sort of data too, which is nice, right? Like, you can correlate things with other things. But the other part of that project that I did was that I took all these data that I had, like 512 channels, hours and hours of recording, and I went into this thing called criticality theory, which suggests that the brain operates at a critical state. Like in physics or statistical mechanics, you have this thing called phase transitions, right? The long and short of it is that critical phenomena also appear to be complex in terms of like information complexity. And that sort of led me down this rabbit hole of understanding, or at least attempting to understand information structure of the brain and information structure in general. And by and large, what you have is that when you have a complex system, like if you have neurons, like all sorts of neurons firing, you could look at that in terms of like binary raster plots, like little black lines on a white background indicating when a neuron spikes. When you look at like hundreds and hundreds of neurons spiking, you don't get something that's just like on, off, like a seizure. No, you get something like complex data. And that complexity implies uncertainty. And sometimes people even consider it to be akin to entropy or surprise. The more entropy or complexity you have in the data set, the more nuance there is. A lot of actual information content is in that, because you have more unpredictability in the structure of the information, right, of the spikes. So literally mathematically, the truth is just far more nuanced and harder to parse than a lie. A lie can be easily constructed, offhanded. It could be just not representative of reality, but just easier to parse. You know, that's just mathematically how it works. So, you know, are we hardwired to prefer lies? Well, we're hardwired to prefer narratives that are cogent and make sense. And a well-constructed lie can be just that, right? I don't profess to understand everything, right? Like that's why I'm in science, is because I want to understand more, and I'm willing to be wrong. It's just that you have to read a lot, and you have to really get into the weeds of things, and that sort of detail. It can be overwhelming, and you don't necessarily know what's true. So you do the experiment to figure out what's true, or at least what's true in that particular context, right? We're all blind men touching at an elephant, trying to figure out what reality is, using our very selective sensors that use a proxy for ground truth, which can be made irrelevant, outdated, broken, or not calibrated properly. And then we're trying to figure out, okay, in this particular context, okay, this elephant has a bushy tail, this has a tusk, you know, like, oh, it's got thick hide. How does this create the whole, you know, nature of the animal? None of us can actually see all of that all at once, right? And in fact, you know, our senses are, of course, very, very limited, right? So are we hardwired to accept lies? In fact, our perception is a lie in a way. Visual information gets flipped in the brain. It hits the retina upside down, and the brain flips it, right? You're familiar with that, right? So already at the first stage of information processing for parsing your own reality, it's already an illusion, right?
There's already a conversion happening in the first instance.
Oh yeah,
yeah.
Oh yeah. I always got a kick out of telling that to undergrads. You know, your reality is an illusion. You know, it really is. We don't know how these sort of things work. How the brain parses the time series of like piecing together images to form a conscious subjective experience. It fills in gaps. You assume things all the time. You only focus on certain things at a time. So, it's very much that the brain just deals in relatives and changes, and it's not necessarily an absolute ground truth finding machine. That's why you need to have help from basic thought processes to organize your thoughts, and very accurate machinery to actually get at what the truth is, right?
This is where ideologies come in as well, because they shape your right? This is where ideology, right? Because if you wear rose-colored glasses, everything's red. So if you think that the whole world is built on racism and power, the entire world, everything you look at, is the cause of it is racism and power versus human interactions.
Yeah, absolutely. So yeah, there's a huge top-down component of it. And even, funnily enough, in Korea, I'll tie this back to what I know about. I speak a couple of languages, not well, but I'm getting there. In Korean, you have the concept of blue and green. Cheongsek could be green or blue. Cheongsek, blue color or green color. it's just the way the language is set up to deal with a particular shade of blue or green. Like jeans can be, I've posted this on Twitter before too, but jeans could be 청바지, which is blue pants, or there's also a thing called a 청개구리, which is a green frog, which is like a kid who doesn't listen to his parents or whatever, like kind of a rapscallion. Two entirely different colors from our perspective as Westerners, right? Or from you know, the Western lens, pun not intended but appreciated. The idea that you can have two different colors be the same color with one word. Obviously, there's also a strict Korean word for blue, like parang, right? Parang색. But the fact that you have two of them being the same color reflects a hierarchical organization of the language and a good enough aspect to decode what you see, right? But when you start to look at that, that's basically like a fundamental understanding of the world, color, right? And even then, has this structure to label it that doesn't necessarily reveal how it actually is, right? When you start to apply that to other things or societal constructs, like how you do something or how you act in a certain way, and you label it in a certain way, almost like a Russell conjugation, if you will, you get this very much, you start to see, yeah, society has a huge way of influencing how we understand the world, right? Like I could be labeled, right? Wesley Smith, international scientist, or Wesley Smith, international conspiracy theorist, right? You once you label something with enough authority, right, it becomes the truth, right? Basically, sort of almost like a 1984 view of it. There are other ways of looking at it, but like I often like to think about how, you know, we really have a super limited way of understanding the world. The way an insect might see colors is very different from how we do. They have access to different wavelengths of vision, right? And a person who can see, or an animal that's transgenic, that has, you know, access to different rhodopsins, might see colors differently from how we do, right? And that's color, right? There's a whole spectrum of information that we just miss out on. So, like I said, we're very limited.
Yeah, I want to hit on 3 points. I think you and Kevin. I mean, it's. I mean, this is totally unexpected that this thing is coalescing to this issue. Like,
I mean, sorry.
Yeah, that's how podcasts work. But anyway, can I just briefly summarize? So I think from Wes we're getting this whole I would say aha moment for many viewers that there's no such thing as a scientific fact. There's just levels.
Oh, absolutely.
Just levels of falsification. There's levels of translation, levels of representation, and that feeds into from what Kevin is saying, an ideological standpoint where everything is deconstructed. You know, there is no objective truth. There's no dogma, or you reject dogma. Okay, that's one half. The other half is back to Wes, that we have patterns, or we use like a shorthand. I think heuristics might be a good word to use. Like we use heuristics to interpret what we're seeing, you know, and heuristics are supposed to give you kind of a way of making decisions. Now, back on Kevin's side, that also translates to this ideological issue of, okay, there's no objective fact, everything's relative, but I choose to interpret everything as oppression. And that's where all the wokes come in. Okay, now back to Wes. This is where the question comes in. Is that a natural outcome of our kind of our hard wiring again, back to the neurology? Or, well, if you want to answer that, good. The next step is there a better way of doing it? I mean, given our neurology or given our makeup? Because my assertion would be the status quo is really just not productive. I mean, if we can all agree that nothing is really true and we're just interpreting stuff, but then you get into the woke philosophy where, okay, I'll just interpret everything as an oppression. It doesn't give you much to go with, right? I mean, from a decision making. Yeah.
Right. It doesn't. But so you have to accept that it's what you do with that knowledge that's what's important, right? So the idea that you have that there's no such thing as truth is either liberating or it's enslaving, right? You could use it to say, well, nothing is true, so I'll just do whatever. Then you're really just becoming a sort of slave to your own desire to do the easy stuff for yourself, basically. But the real hard thing, the liberating thing, is to think, well, then let's try to understand it a little bit better, right? That's there's a bifurcation, right? It's either if there's no such thing as like you have to understand this too. Like if everything is a story, like how we understand the world is a story and an interpretation based off of our limited understanding and limited tools, right? Clearly we exist, right? Clearly, like
we have to agree there at least on that level, right?
so okay, things cast, as we can see, a shadow, right? I can feel like this mug that I'm holding casts a shadow on my table. Like I can visually see there's a shadow. I can feel the weight of the cup, right? Like, although I don't have a perfect understanding or absolute understanding of everything, the EM radiation coming off of the cup, or every molecule, or the orientation of everything inside this mug, every electron position, like at the mesoscale of the phenomenon and the conscious subjective experience of this cup, it's totally there, right? So there is some sort of good enough approximation of reality, and when you realize that, there are good enough heuristics that we can use to parse that, right? And that's whether or not people have been cognizant of that. That's what science has been doing, is to take things that are evident to try to understand them a bit better. The woke ideology, as far as I understand it, just immediately just kills all that and just says everything's relative. Contextually, you can find a good answer for things. Contextually, with the right tools, you can get to some sort of certainty about certain things. Some of it's always going to be a little bit uncertain, right? But you can build bridges, you can build spaceships, you can build silicon nanoprobes, you can build all sorts of things. You can build societies with heuristics to understand and approach certain problems, right? Rather than just saying, oh yeah, none of it's real. No, it's definitely it's all there. You just don't understand it well, and that's supremely arrogant, if anything, to just say, oh yeah, well,
right,
you can do
right,
whatever.
That's why I hate Neil deGrasse Tyson so much, right? Because he's so arrogant. He's like, when it comes to explaining things, he's so arrogant. It's like you see the difference between someone who questions, like, who's the Japanese guy from University of New York, right?
Michio Kaku?
Yeah, Michio Kaku, right? He's humble and he loves learning, and he loves, so there's one aspect, and that's him, which is just beautiful. And then the other, which is the arrogance, was just Neil deGrasse Tyson. In my humble,
I actually don't know if I'm not sure if it's Michio Kaku, but it sounds right. But yeah. I haven't paid attention to Neil deGrasse Tyson in a while, and that's not to slight.
That's the arrogance, using science as like a beat you over the head. Rather versus the questioning boy of wonder who's now in his 70s, right?
Right,
so,
and that's what science is like. You just don't stop questioning. Like you take what you know, and if it's resistant to further questioning, that's a good enough approximation of the world, right? You acknowledge that you don't know certain things about it, but then you use that as a basis for understanding other things you don't know. And if it fits, great. If it doesn't, then you learn something new and you try to make it fit eventually, right? That's where you get things like basically out of that you can get higher understanding of how reality works, right? But if you don't, then you suddenly can just start justifying anything under science. You can just say, yeah, well, it works this way because scientists say so. Like, okay, which ones? How do they reach that? What sort of statistics do they use? What sort of equipment did they use? Did they meet and discuss this in private while having simultaneously or previous opposing thoughts? And then did they all come out of that meeting a little bit richer and a little bit more in agreement? Like there's a lot.
It's like the PCR tests, right? What's the threshold of the PCR test, right? You know what I mean? Because you can crank that bitch up. Now everybody has COVID, right?
Exactly. Or if you don't acknowledge how people misuse them, or if you don't acknowledge how kids were pouring orange juice onto them and getting false positives so that they could skip school. Like, people have motives for doing things in a certain way, and if you ignore that, you totally miss out on all sorts of variability in your data, why they would be a certain way. there's that word data. I thought we were supposed to talk about data, and here we are
Yeah,
talking about
I was gonna get to
fundamental
that.
understanding of reality.
Yeah. Well, I think you guys are coming to a more, I think, fundamental problem we have now, especially in data, which is it's very hard to distinguish between like real, I would say, scientific method where you have a theory or you have a hypothesis, and then like the deductive approach, you have a hypothesis, you do the data analysis, and if the data agrees with your hypothesis, I mean, maybe you're onto something. If not, then better luck next time. And then kind of the, I would say, probably the more popular approach now, which is the inductive approach, where I just have a lot of data, I'm just going to look for some pattern, and then suddenly it's true. Or even the worst one, I think both deductive and inductive approaches have value, but then there's the more nefarious one where I already have a conclusion I want to support, and I will cherry pick the data that supports that conclusion.
Absolutely.
And that's
Yeah.
that's propaganda, right? So how do we, how, well, is there a way of checking? Maybe that's one approach. And then second is how do you now navigate a world where it's kind of a big mishmash of all this stuff?
I'm guilty of the second one a lot, because when you use high density electrophysiology, you kind of just, I call it hypothesis enabling, right?
Yeah.
So you don't necessarily might not have a hypothesis at first because you don't understand how the brain works. To have a good hypothesis, you have to have read a lot, and you have to have a pretty decent understanding to make a projection like, okay, I think in this case, X will happen. If it doesn't happen, then you've learned something and you maybe can figure out how that circuit works in a different way. But when you cast a wide net, you're using that inductive approach, right? It's less common, or it's becoming more, it was less common in the past, it's becoming more common now, right? It's exploratory, you could call it that, that's sort of a euphemism. But I'm guilty of that quite a bit in my scientific work.
If I can interrupt, I don't think it's such a bad thing to begin with. It's, as you said,
A lot of people,
it generates hypotheses, but you have to then test the hypotheses to see if it holds.
Exactly. That's where the statistics come in. That's where you go in and do your drug applications or your optogenetic perturbation of the circuit or whatever to see if you were right or wrong. And I think that they both have their uses, of course. The scientist just keeps asking questions. The propagandist has an answer, and then it makes the question fit that, right? So how do you deal with that?
I am the science, like Fauci. You can say I
am the science. I wanted to discuss this actually with you guys. Basically, we have issues in science where there's reproducibility problems, right? Data just don't add up when someone else tries to access it or tries to reproduce the experiment. And that goes back to like what I think about data. When I think about data ethics, I think about like essentially scientific ethics and academic scientific conduct ethics. Are you collecting the data properly? Are you interpreting it properly? Sorry. And that's a whole can of worms. You can request data from a lab, right? Maybe this is sort of tangential, but it's related to data ethics. You can go and read a paper and say, this is very interesting. They have beautiful data sets. They have very interesting, electrophysiological brain signal result. I want to talk to this group and see the data for myself, right? Trust but verify is I think it should be a common heuristic for understanding various things, especially in science. Trust but verify. So you say, oh, hey, you go to that lab, you email them and you say, hey, can I take a look at your data, right? Or maybe you don't email them. Maybe they already have that disclaimer in their paper. It says, yeah, data are available on this website. And you go to that website and maybe there's a form that you fill out, okay? And you fill out the form and say why it is that you want that data, okay? That's interesting. They want to know why I want it, okay? Okay, fine. So there's already some aspect of gatekeeping involved in there. And then you fill in why you want it. You maybe say who you are, what it's for, and maybe they give you the data or maybe they don't. Like sometimes people just don't answer you if you want their data. Like the academic journals should make it very strict about how you store your data and they say they're strict about it, but in actuality, they really don't have any teeth. So someone can just ignore your request for data and they'd still be fine with that paper being published, and it would still be online or in print. And they could say that, yeah, the data are there, but how are you going to get it? You have to request it. Not only that, let's say you request it, their data are formatted in a particular way that you don't have access to a way to analyze it. Like let's say it's gigabytes or petabytes of spiking data. Like, do you want to analyze the raw data, or do you want to analyze the data that they analyzed already? Like, do you want to have access to the raw stuff, or the cooked up stuff, or the partially analyzed stuff? Do you have the programs to use it? Do you even know how to use the programs? I don't want to name names, but there are labs who create very very interesting software to analyze neurophysiological signals, and some very prominent institutes and other labs now use that software. But to parse their data, you have to then also use that software, and no one's going to teach you how to use it. Like, you got to figure it out for yourself, right? It's not like someone from their lab's going to fly over and teach you how to use that software. You have to actually be good enough at code to figure it out, or read the methods, or read the manuals. If you can't do it, you're at just SOL, right? So they'll say that they've made every effort to accommodate data requests, but it's the impetus is on you to figure it out, right? So when someone says, data are available, most people either can't verify it, won't verify it, or
it's not really even true that it's actually available. They just say it's available.
Like, there's so many issues. Yeah, exactly. There's so many issues with that. Like, okay, so let's say someone wanted to, this is even applicable to me. If someone wanted access to my data, okay, I could say, yeah, I can give you my MATLAB files, okay? I have code, I tried to comment out my code, but I have limits on what I can do, right? This is a logistical issue too. Like I said, in that particular lab who sends their software to research institutes, there's literally no one who's going to help you hold your hand to figure out how to deal with that data. It's just impossible to do. People have a life. They have their problems they're working on. Same with me. If you want to see my data, I can provide that, right? I can provide sort of analyzed MATLAB files, and I've commented code, and I'll let you look at it. But like, I literally have no time to go over how I did certain results.
Handhold you and take you through it. That's on.
I can't do it, and most scientists can't, right? And that's regrettably how it oftentimes works. Now, if you wanted to see the raw data, I don't have the raw data. You have to talk to my doctoral advisor about that and see if they have the raw data. Some people store it on tapes. Some people store it on hard drives. Like, now you're getting to like, how are you going to transport petabytes of data? Like, over, how does that work? That's a logistical concern, right? And that's just one aspect of collection, retention, and post hoc analysis of data that is oftentimes unverifiable, right?
I don't know if this is actually a thing, but since I came from a more corporate background and then later got into the academic side, like, my background is in finance, so I used to do credit risk scoring and algorithmic models for trading. And one thing we always grappled with was this issue. I think it's now called data drift, where you have a data set to train a model. You got to expect that model will deteriorate over time, like, because the total population will never be the sample that you got. And that drift is actually a trigger for a recalibration of the model or a redevelopment of the model. And then, for some reason, I don't know if I'm just seeing another small sample of academic work, that seems to be, in a way, glossed over in many academic literature. Like, and that leads to your replicability issue, where, okay, we did this model once upon a time and it predicts, like, people have a bias. Social science is guilty of this a lot. You got to expect that model will deteriorate after a few years. The patterns will change slightly, or maybe some of the coefficients will even flip. And then, for some reason, people are so shocked about it. Like, we can't replicate this study. It's actually not true. And I'm thinking, didn't you just have that thought at the outset that, I mean, it's too much a bias for natural science, where, galaxies spin the same way forever. I'm not even sure if that's true, and you got to expect that's true.
But in biology, drift happens all the time. But
exactly.
Drift is the nature of biology, right? Like, that's evolution. Yeah, like in lab animals, this thing happens all the time. You have different strains of mice that have been selected for or not selected for certain characteristics, right? Like, C57 mice are a bit more psychos than other types of mice, right? And there have been multiple studies. I don't know the names of the studies offhand. I have it saved on my hard drive, but basically you can look up variability in mouse strains, behaviorally, various other measures. Behavior particularly is important for me as a neuroscientist, but of course, if you isolate a strain for long enough and inbreed them, you're gonna get differences, and that should be something that we talk about.
Yeah.
Yeah, it does get weird. So only recently have people been like outbreeding mice to restore some lost function mentally and metabolically. These things people just take for granted, factoids about how certain things work. They don't. In actuality, oftentimes to construct a project, you have to think from like first principles about these things. Like, yeah, if we want to do a behavior protocol, are mice the right thing that we want to use? Or do you want something a bit smarter? Or do you want to outbreed our mice? Or like all these things come into play. So yeah, their drift is definitely a thing that we should be thinking about. We always haven't been, though.
Yeah, that's true. And I think going back to that point about heuristics, in the public domain, the public isn't used to kind of the issue that something that you might consider fact a couple of years ago might not be the case now. So it's not I mean, I can say it's not comfortable for most people. Like, you want your scientists to tell you with conviction that this is true or this is false, and then it worries you when the scientists are all contradicting themselves. But then that's the nature of science, right? You're supposed to
to be
question,
you're supposed to be contradictory to other scientists. Like, we're supposed to actually fight, like not physically, but like we're supposed to actually debate things. That's like the nature of dialogue, right? Dialogos, right? It's like two speakers, right? Or two discussions happening. Like, you figure out what the actual nature of the problem is contextually, and you go from there. Scientists often should be incorrect, and that's why you get second opinions from doctors too, because one doctor thinks one thing. Like, if you're only getting one opinion from your doctor, from one doctor, you're probably going to have a lifelong health problem. You gotta like deal with that like in multiple different ways, right? And see what it actually is.
One of the things that struck me is when I realized when it was revealed that the Lancet was used to silence opposition based upon political ideology, right?
Yeah.
And how that was the biggest retraction in scientific publishing and in recent history.
Well, big retractions happen all the time. Yeah, exactly. So like in grad school, I learned that like there's this thing called retraction watch. Like, you can see like science and nature have the biggest amount of retractions. Like, oh boy, it's actually not that great to publish in those journals. Like, what's the prestige really if they keep getting retracted? People just fabricate a lot of stuff.
And then you find out that this goes back to the whole ideology aspect, is that the dissent is silenced, open debate is silenced across all media. You just got deleted off of LinkedIn of all things. You know what I mean?
Yes, I have been banned from LinkedIn. So there's my professional network.
For stating scientific fact that was published.
Well, I try to. The funny thing is, I literally oftentimes would just put abstracts, links to papers, and links to Pfizer's data that was mandated to be released by the court, right? Legally openly available documents. That's odd, isn't it? That's a little bit odd.
Right, you linked Pfizer documents. You linked the Pfizer documents without comment, and then they're like, "No, you gotta go."
There's some comment. At one point, I said, "Okay, mRNA transfections are indeed gene therapy because it's nucleotide prodrug, and then it creates a drug or a ligand in your body. That's literally what transgenics is. You just call a spade a spade. When you do something that injects a gene for something to do something as a therapeutic, it's literally gene therapy. Like, from first principles approach, understanding what do words mean things? If they mean things, then it is gene therapy, and people are signing up for gene therapy. And to me, as an aside, this is like, I try to not wake up in terror every day, realizing like I was doing gene therapy on rats in 2011, 2012 to make them experience seizures, to understand how seizures propagate in the brain. Like, gene therapy should be restricted to the lab for most cases, for 99.999% of cases. It's supposed to be something that we use as a research tool to understand how things work, right? Suddenly, when you get billions of people to sign up to take something without truly knowing what it's called or what it is, I just, every day, guys, I'm just like blown away. I'm just literally blown away. And I try to just not think every time I think about it, it's just terrifying. That's revealing a lot about me, but I'm not some sort of Luddite, or maybe I am a Luddite, depending on how much you actually know about the Luddites. It should be cause for concern, and I said that, I think, in a LinkedIn post. These are transfections. This is cause for concern. You should look into this. You should understand. Here are some papers about integration of exogenous genes into the genome through things like theta polymerase. How exogenous DNA can interfere with endogenous replication machinery. There are papers on this. Rare things can happen, especially when you do it when you're introducing 40 plus trillion copies of a gene, and in 6 billion, not 6 billion, but however many people. We don't even know how many people got the injections, but rare events become common.
Right.
Law of large numbers.
Right, I know. It's really interesting. If you don't like the science, just change the words.
Yeah.
If you don't like the scientists, just ban them off of social media.
I've been shut down social media altogether. That's another option.
This is the thing too. I've been harassed on various platforms, and so one of the things is that, like, that's why I'm private now on Twitter. This is probably one, if this is published, right, openly, this is one of the first times people will actually have access to my thoughts on a variety of issues, because most of the time it's been hidden. Although I have a Substack that is openly readable, but I don't really post on it. So yeah, I mean, it's you got to follow the silence, if anything, not follow the science. Follow the silence. See which scientists are blocked, and then look at them.
Look at the road less traveled. Anyway, Wes, we're coming to the hour, and of course, this is an endlessly fascinating topic. But maybe we can save some for the next one. So maybe I know this podcast went in an interesting direction that none of us could have predicted. Any thoughts that you would like to share to the viewers before we close and then wrap up?
Question everything, because if you don't question everything, then you're just living out someone else's ideas and ideation, and that's not really a life that's fun. Gotta question everything. Question me too. That's the only way to. Like, I don't know everything. And I've said that multiple times. I just want to figure out what is and what isn't, right? We could probably have the other discussion about data. I marked things on Twitter, like, we should talk about this. We should talk about this. Like, I wanted to talk about, like, pangolins. I wanted to talk about, like, editorial responsibility in journals. And yeah, we didn't even talk about that. We didn't talk about various other.
We'll save some for the next one. Definitely. I think we're racking up a wish list now, and it's great.
Am I going to be a repeat guest?
Oh yeah, definitely. Especially after today. I mean, there's just a lot of crossovers between how science is done, how ideologies are developed, and my personal interest still, maybe for the next episode, is I'm more of a structuralist by ideology. So I think that there is some hidden connection to all of this, and maybe that's really where the brain comes in, and that's your work. So yeah, we can get into that next time. Yeah, Kevin, you want to share any last words before we go?
Yeah, a lot of this comes back to the power of myth and how we see the world through different archetypes, and how we subscribe to ideologies. What I have seen is you can have the same information of data in front of different people, and they will see different things.
Absolutely.
And what you said earlier in your conversation was that you need a different set of frameworks to see how everything fits together. And so I guess that goes back to the concept of thin slicing. We thin slice various things to find the elephant in the darkness. You know what I mean? So understanding power structures, understanding ideologies, understanding the World Economic Forum, why a lot of the things are done.
That was one of the things. Did you see? That was one of the things I posted on LinkedIn before I got banned.
We should talk about how to get banned. I mean, as a topic, it's interesting.
Mention the Bilderberg group on LinkedIn.
Bilderberg,
instantly
the Illuminati, and the New World Order. Yeah.
It's literally a thing, though. The Bilderberg group is actually a literal thing.
Yeah, I know. They took over the whole Mandolin Hotel, and the people tried to go in there. It was hilarious. Anyway, my thing is, we all have ideologies, we all have frameworks, And one of the best things I think that we can do with data ethics is to break ideologies down so that people can see things more openly.
Yeah, transparency. It's always a good
I think
start.
that's what data. I 100% agree with you. Like data ethics, it's really a transparency and communication issue. Like, are you hiding data or not? And thus, is your science interpretable or not? Right? That's like the key of it. 100%. And I do think also, I know we're running a bit late, but I wanted to also say, Kevin, I really like that sort of that ethos that you have there. And it's important that we all think differently. We also have different priors, right? Like when I go to a lab, there's 7 or 8 other guys there or gals. They have different, they can't have possibly read the same papers that I did or done the same experiments that I did. So they approach things with their expertise and their knowledge, right? And then we work together to understand a project, right? So we don't all think the same. We'll read a paper and we'll have different critiques of the paper and different understandings of the paper, you know? And that's the beauty of it too. That we're all
open source. That's why I love open source. Many hands build.
Yeah, exactly.
All right, I think that's a good place to end it. So thanks a lot, Wes. Hope to have you on the next one.